My name is Charan and today I'll be presenting my project Multi-Language Code Runner using Docker. This project allows user to write, execute and view outputs of code in multiple programming languages all from a single web interface. It's being built with React.js for frontend, Node.js with Express for the backend APIs and Docker to safely execute user code inside isolated containers. Traditionally, to run code in different languages like C, Python, or Java, you have to install compilers and interpreters separately on your system. This becomes difficult to maintain, especially when multiple users or languages are involved. My project solves this problem by using Docker container. Each Docker container has all the compilers pre-installed in it. So users can simply write their code, select a language, and the system will run it securely inside the container without affecting the host machine. Overall workflow is quite simple and efficient. When the user enter their code and select a language on the front end, the React app sends their data to the Node.js backend API. The backend then passes this information to the Docker container, which runs an internal script called run.sh, which is a shell file. This script compiles and executes the user code using the appropriate compiler, for example, GCC for C, Python 3 for Python, or Java C for Java. Once the output is generated, it is sent back to the backend, then displayed on the front end instantly. In my project folder, I've separated everything into three main parts. Here is the front end folder. This is used to build the user interface with React.js. And this is the backend folder. This is written in Node.js, which contains route, services, APIs that communicate with Docker. And this is the executor folder. This contains the Docker file, the run.sh shell script, and the language file that maps each languages to its compiler command. This Docker file uses an Ubuntu base image and installs compiler for all major languages like C, C++, Java, Python, Go, Rust, etc. I have implemented around 25 languages in this project. Once built, this image acts as a blueprint for the container. Whenever code is executed, a new container is created from this image, the code runs inside it, and the container is removed, ensuring complete isolation and security. Now I'll show you how the system works. First, let us start the backend server. Now, let us start the front-end server. On the screen, you can see the front-end interface. I'll type a simple Python print command, print cloud computing. As you can see, the output is getting printed. Now, let us try a more advanced code. I'll change my language to Java. Now, let us paste a Fibonacci series code. Uh, as you can see, the output is displayed. Here it shows the Fibonacci series. This system works for any languages. I can quickly switch to Python or C or rerun it without any reconfiguration or rebuilding of containers every single time. And now for the container management, I use Docker Compose to run multiple containers simultaneously, one for the backend API and another one for the code executor. I also pushed my image to Docker Hub so that others can easily pull and run it on their systems. It can be pushed using these commands. This ensures portability, so my whole setup can be replicated anywhere without manual compiler installation. So to wrap things up, this project, the multi-language code runner using Docker, basically brings together everything. The front end lets user type their code and pick a language. The Node.js backend handles all the communication and sends it to the Docker container where the code is actually compiled and executed safely. What's great is that it works across so many languages without needing to install anything manually. The Docker takes care of all that inside isolated environments. It's lightweight, scalable, and ideal for use cases like online coding platforms, learning environments, or automated testing tools. So overall, it's a clean example of how backend, frontend, and the developer tools can work together to build something powerful, scalable, and easy to use.